Hi, everybody. How are we doing? Good pizza, good beer, right? Okay, great. So I'm going to talk about Kubernetes plus Mesos, which I think can be a controversial topic because a lot of people see those two things as being competitors in some ways. And in some ways there is overlap, and we want to talk about that. But in some ways we want to also think about how these two things can work together. And certainly from my company's perspective, Mesosphere's perspective, we see these two technologies as being interesting ways to go about solving similar problems and sometimes different problems. So how many people here have heard about Mesos? Yeah, everybody? Okay, good. Heard about Mesosphere? Okay, fantastic. So it's going to make my job very easy. All right, so a quick introduction. So thank you. I got introduced as the head of developer advocacy. That's right. I also work with our open source communities. Carl Eisenberg is a distributed applications engineer. He's the one that actually created this presentation for KubeCon last year. So when a couple folks saw that, they said, you got to come out to our meetup and give that same presentation because it has interesting content in it. So the good news is if you hate this presentation, it's not my fault. If you love it, it's probably because I made some really important changes to the presentation. But Carl's a great guy, and you can also reach out to him if you have more detailed questions or if you want to talk to a guy who writes the code on a daily basis. I love to start with this quote, and Satya is not the first one to say it, of course, but this whole idea that every company is becoming a software company. The reason I like it is because it helps to set context for why we're doing all this shit. In the world today, there are companies that are software companies that understand how important software is to their business, Microsoft being one of them. But then there's a lot of other companies that are getting disrupted by software companies. Look at Uber or Netflix or companies like this where suddenly software becomes a really important business, a really important way how they compete inside their business. And I think that's really important to think about. The reason we are so excited about what's happening and the revolution that's happening inside the data center is because it's helping companies create entirely new ways for them to compete inside their business. This software isn't just about running the business anymore, it's about how do you compete within that business. And that's really cool. So that's why I'm so excited. That's why I think this is a really interesting space, and it starts to help create the context for why I think data centers and the whole conversation we're going to have about data center operating systems is an interesting space. So first and foremost, let's just recognize the elephant in the room. This is a complicated space. There's a lot of different players, a lot of different frameworks, a lot of different ways to configure a successful data center. It's not as though there is only one solution to this problem. I think what we hear a lot is, I just want microservices. I believe in this strategy. I believe in creating applications that use microservices. How do I do it? What the hell does that even mean? I see all these different applications out there, these different frameworks. How can I take advantage of it? Where the hell do I start? Do you even lift, bro? So the idea here is, I think we have an opportunity to try and create some sort of order to this chaos. And I think what I'm going to try and do in the presentation today is help to provide a potential way of thinking about this chaos. It's not the only solution. I'm going to go back to saying that 100 times over. It's just one way that we think about how all these different pieces fit together. And hopefully in the end then, you'll see what I'm talking about in terms of why Kubernetes and Mesos can live together and should live together within a data center. So layers. So not just something you need when it's cold outside. We see this as an opportunity to think about this stack in terms of these layers. Now again, this is the way we think about it, but don't necessarily feel prescribed to this. At the bottom, machines, whether it's the cloud or whether it's something on premises, this is where the lights blink. On top of that then is provisioning. So this is what you do to actually make the lights blink. How do you actually get those servers up and running? How do you make the cluster, get the cluster provisioned the way you want it? A lot of interesting technologies there. Certainly a ton of interesting technologies down in the management layer. Now, resource management. So this is one where it's all about the individual servers. How are you actually taking and managing the resources within those individual servers? Mesos is a particularly good technology at doing this particular problem. Now, you'll see as we go up the stack, there are other technologies that don't necessarily care about it at that level, and that's okay. But Mesos is one way to think about the resources within each of those individual servers. Next thing above that, okay, how do you actually containerize? How do you create applications that can then go into those servers and run the workloads that you have? Tons of interesting technologies here going all the way back. Mesos is actually a containerization technology that existed before Docker, but Docker has come along, done a great job since then. Job scheduling. So now how do you take those containers and actually schedule them across an entire set of resources? So now you're not just thinking about a single container running in a server, but how are you actually managing that across an entire data center? Then the orchestration on top of that. Application orchestration on top of that. So this is the final layer at the top. How are you actually managing your applications? This is where you start to think about source code, right? What's in your application? What are the pieces of that? Okay, so a lot of different layers here. Why do we lay these out? It's because we want to show that there are strengths and weaknesses to different technologies running within different layers within this diagram, this architecture. So when we talk about why would you want a Kubernetes plus Mesos architecture, it's because you want the benefits of what Mesos can offer, maybe from a resource perspective, but you also you have application developers that care about Kubernetes, that are using Kubernetes today. They want to be able to run that in your data center. That's fine. There's no reason why those two technologies can't live together, and I'm going to show in a minute in the demo how we actually run Kubernetes within our data center operating system, and that's Kubernetes running on top of Mesos. And so that's really where we have sort of a stake in this game. We define this thing called the data center operating system, which is designed to create not just a layer that is about one single piece of this architecture, but it's about how do you combine those pieces in such a way that you get something that's actually repeatable, something that you can count on within the data center. So when we think about an operating system, we think about something that manages resources at a high level. And so what we want within within a data center is the same thing. We want to manage all the resources of the data center as a single pool of resources. How do I get at that memory? How do I get at that CPU without having to necessarily manage an individual server here or an individual server there? And if you combine these pieces together, then from an application perspective, you can actually get your applications and containers running inside this data center and not have to worry about it all the way down to the very bottom level. So, as I said, I'm going to show this in a demo in just a second so you can actually see what this looks like. But just in terms of how we think about the world, this is what the picture that we keep in the back of our mind when we think about these different layers. So this is our advice when it comes to thinking about, okay, where do I start? How do I get going with containers? Or how do I get going in general with a modern data center? So first and foremost, understand your landscape. Understand what those different technologies are and the problems that you're trying to solve very specifically. Each organization is going to have different problems that they're trying to optimize for. You want to make sure you understand which layer of that stack is going to optimize for the problems that you're trying to solve. Second thing is stay as high level as possible. Keep this as close to the application level as possible. Get your app developers developing as high level as possible so that you're not having to worry about the details unless you get to a point where you really need it. So maybe you need to orchestrate at the lower level. Maybe you need to create your own framework on top of Mesos because you need that level of control. No problem. Go for it. Dive down when you need to. But if you can stay up at that higher level, if you can stay just focused on Kubernetes, just focused on those higher level layers, then you're much better off. And then last but not least, this is Carl's phrase, chain your tricks together. The idea of how do you connect these different pieces together so that you optimize the use of each of them. So it's not just a matter of focusing on a specific technology because, by the way, these technologies are going to change. So remember, some of these technologies are less than a year old that we're talking about that everybody is so excited about. A year from now, you never know what's going to come down the pipe. So from our perspective, it's really about how do you actually chain these tricks together? How do you get these different technologies working so that if something else comes along, if you have another opportunity to take advantage of a new technology that might meet your needs even better, that you're ready to plug that in. And I just love that picture of Renton Thurston. So let me introduce the three tools that I'm going to now deep dive into in a demo to show you kind of how these things work together. So first and foremost, Kubernetes, I already talked about that. I think everybody here is here for a reason probably. Kubernetes, great for app level developers. So if you're developing applications, Kubernetes, a great technology, a great framework to use for developing those applications. But then beneath that is Mesos, which is a great framework for the lower level framework developers. So if you want to develop something like Kubernetes on top of it, great. That's what Mesos really does well. But it also helps your application developers deploy faster. So this whole idea of how can you actually create a framework, a cluster that's easy to deploy into and it's proven at large scale. So Mesos, runs Twitter, it runs Airbnb, it runs very large scale data centers. So this is an underlying technology that, from our perspective, really underpins the ability to run those apps at the higher level. And then Mesosphere DCOS, this is our product. This is how we take Mesos and turn it into something that has all the pieces that you need running together so that it's easy to use. That's the primary benefit of DCOS. You can take Mesos off the shelf if you want to, but think of Mesos as being a kernel. If you just take the Linux kernel, you don't really have a solution, right? What you have is a great piece of technology, but it's not a complete solution that you could run on a server. And Mesos is the same way. Great piece of technology, but an incomplete solution from the standpoint of what it takes to really run applications in a modern data center. Okay, time for a quick demo. So I'm going to show a few things running inside our DCOS. So DCOS is Mesos with a few other components on top of it. I'll show you what those look like in just a second. I'm going to add a new framework to that repository. We're going to specifically add Kubernetes so you can see how easy it is to install Kubernetes on top of Mesos, how easy it is to get that application level within the layer. We're going to run them pods, and then we're going to drop the mic. That's enough for tonight. I'm not going to be able to go into a whole lot more detail just because there's not enough time. But I'm going to point you to our GitHub repo. I'll certainly be around afterwards to help answer questions or point you in the right direction in terms of how you can go and play with this stuff yourself. Certainly, we want to see folks actually trying this stuff out. It's not just for me. Okay, so my demo cheat sheet. So first things first. Earlier this afternoon, I created a cluster within Azure. Why did I choose Azure? Well, it just happens to be the thing that I've been using this week to run a bunch of other demos. So don't read anything into the use of Azure. You could be running this on AWS or any other platform that you would choose. You can even run it on-prem, of course. Our platform, our DCOS itself is designed to run anywhere. Well, let me just click in and show you what it is inside that cluster. I've got a handful of private slaves. I've got a public slave as well, which I don't know if you can see it here, but let me open it up real quick. A handful, literally 5 private slaves. I've got a public slave, and I've got a master as well. A single master in this case just means that from a Mesos perspective, we don't have high availability, but that's okay. This is just a test environment. You can do 3 masters. You can do 5 masters. If I go into the master, I can get what the public IP address is for that master. Using that, then, I can actually open up the Mesosphere DCOS. So DCOS itself comes with a user interface like this where you can see the nodes, you can see what's running, you can get access to the frameworks that are running on top of DCOS and Mesos. So I'll take a look at what those things look like in just a second. But to start with, this goes back to what I was saying before about how, from a data center perspective, it's not about paying attention to individual nodes and individual servers. What we want to do is talk about a pool of resources and how those resources can best be used then by applications that run on top of it. So you can see within DCOS, what we care about is the CPU allocation, the memory allocation, and this is in total across that data center. So that's the 5 slaves that I have. That's the 1 master that I have.
How does Mesosphere model the CPU?
What do you mean model?
Does it do cores or megahertz? Or?
Yeah, cores today, and we're getting more specific on that. So I've actually already started a few services running, so we'll take a look at what those are. But this also, just because I was running a different demo earlier today, this also helps to point to one of the important things I think about modern data centers. It's not about running a particular framework and then cramming everything into that one particular framework. It's about how do you best mix these things together to be able to maximize the effectiveness of your application developers. Sometimes it's 1 framework, sometimes it's 2, sometimes it's 10, oh God. But we want the ability for you to be able to manage that within a single interface. If I go look inside the nodes, you can see the individual nodes that I'm running as well. You can see the usage, both CPU and memory, across those nodes and across the different applications that I'm running. In addition, I've installed the CLI. So this installs locally, gives me the ability to actually manage this cluster through a CLI as well. This is how I'll actually install all the additional packages that I want. It's how I'll actually see how the nodes are performing. So I did all this ahead of time only because it takes a little time to do it, but it's easy to actually do. If you come in here, when you first open up the GUI for the first time, you go to the IP address of the master. It gives you the command that you need to actually install the CLI locally. Just copy, paste that, and then you're ready to go from a CLI perspective. And the tour is fantastic. So first thing I'm going to do, I'm going to add in an additional resource So an additional set of resources. Go back here. So the DCOS has the ability to attach to different repositories. The interesting thing about this is we come with a set of packages and frameworks that are available to you. We also make it available for you to be able to install your own frameworks at any time. Kubernetes is one of those frameworks that lives in what we call the multiverse. So the first thing I'm going to do is install that multiverse. Great. Now I have access to those packages. I'll just do a quick package update, and then I'll install Kubernetes from there. All right, now all those packages are available. So if I do DCOS package install, sorry? Oops, got to spell it right. Kubernetes installing, yes. So now what's this doing? What is this doing? It's going out to our multiverse. It's actually downloading Kubernetes into my data center, getting it installed and configured and getting it running. So I want to go back to sort of what this means from a data center operator perspective. So today, if you try and run Kubernetes in general inside a data center, we've felt the pain of trying to get that thing running. It's not that it's hard, it's just that it takes time, it takes energy. And we know that that's true for other frameworks as well. So if you get Spark up and running or Kafka or other frameworks as well, that pain of getting those things working across an entire set of nodes can be painful. What we've done instead is made it so that the management of that happens within the data center operating system. So with a single command now, I've installed Kubernetes, and it is now running inside the DCOS. If I go back here to the GUI, it might be the easiest way to see it actually running. So now I have Kubernetes running. It's idle, of course, because I haven't actually started anything inside of it. There's nothing happening with it. But it's there, and it's ready for me to use. So now I can drop my pods into it, and I can actually start using it. These other frameworks, of course, are already up and running. They've been up and running for a while. If I jump into Kubernetes, the other interesting thing about this is every time you install a new framework, it not only installs the actual framework and gets it running, but it also installs the commands that you need within the CLI, and it installs the UI that you need within our GUI. So this comes with all of that specific UI from Kubernetes. If I click here, open the service, you can actually see this running then inside the Kubernetes GUI. So as you get new frameworks, as you attach new things into this and get it running on top of Mesos, easy for you to manage it all within a single location. And same thing's true within the CLI. I'm going to quickly install kube control just so you can see what that looks like. So you still have the same commands that you would expect to have on the CLI for Kubernetes, just available now through DCOS running on top of Mesos. So I'm going to go to my demo. So now just to sort of do a quick hello world, I'm going to get Nginx running inside the Kubernetes so we can actually see it running then inside Mesos. So a couple quick commands here. So now I've created the web service. I'm going to quickly get that up and running. Good. Let's go check the pods now to see that it's actually there. Good. So it's pending. It'll be up in just a second. Then from there, I can go in and actually show that we have Nginx up and running. What I have in the demo, in our complete demo, is actually much more interesting from the standpoint of the actual data that we get running. I'll show you what that looks like in just a second, but I didn't have time, unfortunately, to go into that in a whole lot of detail in the session today. So let me go back here real quick. Just reload this, and welcome to Nginx. So this is the IP address of the master, and then just appending that actually shows us the status of that particular service running inside of Mesos. Okay, that's the quick demo. Like I said, I know that's fairly incomplete from the standpoint of being able to show the gory details of how these things work together, but I think also from the standpoint of just showing the fact that we run Kubernetes on top of Mesos, we do that for a reason. That's really the point here. We can easily get these two technologies working together. If you want to use Kubernetes as your application layer, that's great. Easy for us to make that possible. I'm going to jump back here. I have a couple screenshots here that just show in case things went down. So this is the demo that we've created and that we typically use when we go in to present sort of DCOS at a high level and to show off how Kubernetes works in this whole environment. I'm going to walk through the pieces of this, and then I'm going to point you to it if you're interested. I'm happy to go into more detail one-on-one if anybody wants to actually see this running or talk through it with me. But the idea here is the city of Chicago actually produces its crime data and makes it available to anyone. So what we wanted to do was actually plug that into a DCOS cluster and crunch those numbers, do something interesting with that data. So we created two visualizations of the data. One is the online piece and one is the offline piece, and I'll just walk through the technologies that we use to make that happen. So we have a crime data producer, which is reading from a flat file the data that we get from the city of Chicago. Kafka is just an open source messaging service that pushes that into Spark. From Spark, then, we push that into two different databases. One, InfluxDB, which we use for doing an online demo using Grafana. This just shows in real time what that data looks like temporally, so we can see when the crime happens, how it happens over time. And then we also push it down into S3, which we use with Nginx to be able to create a spatial demonstration of what that data looks like. Just a simple heat map running over top of a map of the city, so you can see where the crime happens. We're specifically using Kubernetes to manage this piece of it because it's designed well for that piece of it. And we're using Marathon to manage the online piece of it at the top. And this, again, I think shows a realistic example of the kind of thing that happens inside data centers that our customers are running today. It's not a matter of having one single solution for everything. It's a matter of how do you use the best tool to be able to solve a particular problem. So this demo is available in GitHub. You can also go to mesosphere.com/product to get DCOS. It's a very simple process to get it up and running inside AWS. If you want to run it in another environment like I did here tonight on Azure or anything else, just reach out to me. I'll be happy to help you get it up and running in your environment. But I think the important thing is we have everything you need to be able to see kind of how these pieces work together, and I think everyone's here is certainly smart enough to walk through that demo. It's not a complicated demo, but it gives you a chance to see all the different pieces working together. This is what you get from the offline side. This is what Kubernetes is controlling from the demo perspective. It's the Nginx that shows the heat map running over top of the map so you can see where the crime is happening. Within that crime data, we get latitude, longitude, type of crime, a bunch of information like that. So you know where not to go in Chicago. Very handy. All right, so that's the quick thank you. So I'm here for the rest of the evening. If you have any questions or if you want to know more, happy to. Eric Goldstein is also here from Mesosphere if you have questions, so certainly happy to help out. Feel free to reach out to me as well, email, or I think you have my Twitter as well. So reach out to me if you have any questions. I'm happy to follow up.
Thank you. Any quick questions?
Yeah, sure.
So what makes Kubernetes a particularly good use case for that heat map as opposed to running on Marathon?
So Nginx, easy to get up and running. So just as I showed there, just those two technologies, we have people in Mesosphere that just knew that out of the box and just said, boom, I can get that up and running in 30 seconds. So in that case, it was more of an opportunistic decision for us. But I think the important thing is within each organization, you're going to find some technology, and you'll find some people that have a bias towards Kubernetes for specific reasons. We want to be able to give those folks a chance to use that in addition to Marathon for the other technologies, et cetera. So I'm not going to prescribe sort of why one technology is better than another, just because I think, not my place.
Yeah, I was just curious if that was a...
It was opportunistic. It was opportunistic, but also from a demo perspective, we wanted to be able to show Marathon and Kubernetes running together. So in that sense, it just gave us a chance to sort of split those two things apart. Yeah.
You have DCOS installed bundle Kubernetes.
Yeah.
How does it configure? In other words, Kubernetes can be deployed in many different ways.
Sure.
When you run it, how does it allow you to configure it further? I mean, obviously, when you ran it, it configured something.
Yeah.
Where can I see how that got configured?
Yeah, so within DCOS, we manage the configuration of those frameworks. So it's not something that that we don't want DevOps to have to worry about the configuration of those things because we want to be able to manage those nodes at the lower level through Mesos. So the configuration is not something that we make available. It's something that we want to take out of your hands. So if there's something in particular where you're like, yeah, but I really need to tweak this one thing to make this work, let's talk about it because there are ways to go into those nodes on the back end and be able to tweak those things. But for the most part, we hope that all that configuration we can take out of your hands. That's our goal.
Wait, Mesosphere in general does that for every service? That you...
That's correct. And like I said, I don't want to make it sound like you can't go in there and hack it if you want to. It's available. You can get into those interfaces and you can use those commands on those back-end nodes just like you normally would. But the important thing is, for 99% of the time, we want it to be just as simple as a package install. That's important. Yeah?
So the scheduling decisions are made by the Kubernetes Mesos framework?
That's correct.
So you just kind of worked out that part of Kubernetes and kind of just made Mesos do that, or that the Kubernetes Mesos framework do that?
That's correct. That's correct. And like I said, that piece of it is an open source project, so it's available. You can come take a look at how we did that if you have specific questions, or I can point you to the folks like Carl, for instance, that can answer.
Watching the resource usage, is that Mesos literally?
It's Mesos, yes. And I think that's important though too. Like, our bias is towards pushing as much down to Mesos as we can. So when we implement those frameworks on top, we push all that responsibility down to Mesos. Now, you could come along later and say, well, I want to actually slice it differently. I want to have my implementation of this framework handle more in this more specialized way because maybe I know more about my workloads. No problem. You can still run that on top of Mesos. But if you take our Kubernetes implementation, it pushes as much as possible down to Mesos.
You running heat store in that Kubernetes implementation?
I don't know. Follow up with me afterwards. Okay. Thanks, guys.